Well, hello there. So yesterday you'd have noticed we had no biscuit, but today we're going to be doing a bit of algebraic division, which is particularly focused at something called an improper fraction, and how we define that's going to be important. Before we do, I'd just like to introduce you to today's biscuit, which comes from a certain budget supermarket down near the waterfront. It's called a deluxe, is it dark chocolate ginger, something like that. I'm looking forward to that. I'll give that a go whilst you have a look at this definition. Right, now the flavours were fantastic on that biscuit, but I must say it didn't have the sort of same crunch that I was expecting, but I've got a feeling it may have been open in the cupboard, the packet, for a little while, so we can't blame it all on that. You'll have to give it a go. Right, so the other thing we need to know is what is meant by the degree of a polynomial. You'll have noticed this in your calculators when solving quadratic equations and such. By putting them in, it will ask for the degree of a polynomial, and the degree is the power of x, basically the size of the biggest exponent there. So it's not 2 because we've also got a power 4 there, so for that reason that degree would be 4. Now, looking at how we sort out an improper fraction, we're going to have two methods, so I'd like you to have a little look at this. You might want to note this down coming up in a moment. So here's our question, and we're going to do this one with the first method. We need two methods because in a minute I'm going to give you another example with basically the same problem but shown to you in a different format, in which case we'll need the second. So we're going to be using algebraic division here, which is something hopefully we all know how to do by now. So have a go at it, pause the video, have a go at it and see if you get to the next bit, and you may be able to go all the way through and see if you can come up with what the whole solution to this might be in this case. So I'm dividing my x just into the x cubed to get x squared, then x squared times x is x cubed, x squared times -3 is -3x squared. I take this from this, gives me nothing. I take this from this and it gives me 4x squared. Drop the -7 down there. Do x into 4x squared gives me plus 4x times that by x gives me 4x squared times 4x by -3 gives me -12x. I've made that good old mistake there, haven't I? That should be -7 there, and I should have plus 0x there, plus 0x, because then when I take my -12, I add the 12 on, so that gives me 12x there, and when I divide 12x by x I get plus 12 up top there, so that gives me 12x, but it doesn't. If I drop my -7 down, this time it's not giving me something that works, and that's because it doesn't divide into it exactly, and we don't expect it to because it's an improper fraction. So if I take this away from here, -7 take -36 is adding 36, gets me to plus 29. That is my remainder still to be divided by x minus 3, which is how this is all going to come out into this answer up here. So what have I got? In fact, I'm going to use red to write this out here as my answer. So what I've got is I've got x squared there plus 4x plus 12 plus 29 to be divided by x minus 3. And that means that a must equal 1, b must equal 4, c is 12, and the d is 29. If we can fit that into the page. There we go. Right, so here's our second example. Have a little look at it. It should look familiar. And that's because it's the same question effectively. If you wanted, you could divide both sides by x minus 3 and you would get the question we had before. So if you spotted that and you prefer doing algebraic division, then that's absolutely fine. But this time we're going to have a look at doing it using equating the coefficients. So what do I know? I know that the coefficient of, so we've got 1x cubed, we've got 1x squared, we've got 0 x's, and we've got minus 7 at the end. That's what we're looking for. And the next thing I'm going to do is I'm going to expand these brackets here. You can have a go at it and pause the video and then have a go and see how you get on. So I'm going to have ax squared, bx and c, and I'm going to have x and minus 3 multiplied by everything along the top by x gives me ax cubed, bx squared and cx, and negative 3a x squared, negative 3bx and negative 3c. So all of that is giving me a x cubed plus, and now what I'm going to do when I collect my terms together is I'm going to use a bracket so I know how many x squareds I've got. So I'm going to say I've got plus b minus 3a, and I've got plus c take 3b, and then I've just got my minus 3c at the end. And now that I've done that, I'm going to look at each of my coefficients here. So because I've got just a x cubed and 1x cubed, I can say that a equals 1. So that's looking at the x cubed there. Now if I look at the x squareds, I've got, so let's just look at the x squareds, and we've got 1x squared is equal to b minus 3a, but I know that a is 1, so it's b minus 3. Therefore b must be equal to 4. Then if I come down to the last bit here, I've got how many x's? I've got 0 x's are going to be equal to c minus 3b. So if b is 4, then that'll be minus 12. Therefore c is equal to 12. But then I still need to know what my d is, and my d is going to be just my constant on the end, isn't it? So for that, so I call the constant c, well anyway, you get it. So the constant is negative 7, it's all going to be adding up to, and that's going to be made up of minus 3c, which is 3 12s 36, so that's minus the negative 36, plus d. And if I add 36 to both sides, that gives me d equaling 29, which is the same as I had before. A equal to 1, B equal to 4, C equals to 12, D equal to 29. So I hope that makes some sense. And we've got one more example to look at where things get a little spicier. So here is our last example, and whilst you're copying that down and thinking about what the flip might be going on here, I'm just going to sample a bit more tomato juice to wash that ginger and chocolate down. Yes folks, that's a lovely way to start the day. Now, what's going on? They're telling us what we've got to divide by. We've got to divide by x squared plus x 2x take 3, but that's a quadratic. We haven't normally divided by that much. Can we do that? Well, the answer is, folks, yes we can. Just set it up the same way as usual. Give it a go, see how far you get, and then watch me talk through it if you get lost. But it's the sort of thing where it's always worth seeing what you can do on this, because that's when you work it out for yourself. When you work it out for yourself, it's all the more satisfying, and it goes in all the better. Now you're still just going to be dividing the first term you look at by the first term that you've got there, and then you're still going to be multiplying all of this lot by whatever you get up there. So x squared goes into x to the power 4 x squared times that by that gets you x to the power 4. I just realised I've done it again. I really do need to put a 0 x squared in there. Can I do that? I think I'm going to have to write that all out again. So by all means you carry on and have a go. I'm going to write that out again, but it's really important that you get used to this idea of spotting this as it comes up. I always do it, but as long as you catch it, then you're going to be okay, and the sooner you catch it and make up for it, the better. So let's not worry about that. So x squared goes into x to the power 4 x squared times x squared times x squared is x to the power 4 times x squared by 2x, and you get 2x to the power 3, times it by negative 3, and you get negative 3x squared. So now we're going to take that from that is nothing. X cubed, take 2x to the power 3 is negative x cubed, take negative 3 means we're going to add, so that gets us 3x squared, and we're going to drop that x down to there. But when I do x squared into negative x cubed, I get negative x, so that times x squared is negative x cubed. Negative x times 2x is negative 2x squared. Negative x times negative 3 is plus 3x, and I'm going to take all of those away, so the x cubed disappear. So that should, yeah, that's right. When I take negative 2, that's adding it, isn't it? So that gets me 5x squared. When I take 3x, that's going to give me negative 2x. Then I'm going to drop that 10 down, and we're going to do x squared into 5x squared, which is going to give me plus 5, and then that's all I have to do there. Now timesing all of these, I get 5x squared. I get 5 times 2x is plus 10x, and I get 5 times negative 3 is plus 15. Now When I go to take all of these away, they disappear. -2 take 10 is minus 12x. -10 take oh, hang on, that's not plus 15, is it? Because it's plus 5 times -3, so that should be negative. When I take a negative, I add, so that's going to give me plus 5 when I add 15 to -10. Now, I cannot divide the x by x squared. As soon as this is why we start calling it improper at that point. So we've got a bigger thing underneath. So that is my remainder. So that's so important. I'm gonna put a little thing around there and say remainder, because what I'm going to be able to do here, remember, I want a x squared. So how many x squareds have I got? Well, I've got all of this up here. So I've got x squared take x plus 5. My remainder is what has not been divided by this yet, isn't it? So my remainder is 12x minus 12x plus 5 all over x squared plus 2x take 3. And what that means is, when I have a little look at what I've got, I can say that a equals 1 because I've got 1x squared. B, I've got minus x, so that's got to be -1. C, I've got just plus 5 there, so C must equal 5. D, what have I got there? I've got minus 12x, so it's -12, so D is minus 12. And E at the end is plus 5. And we've got there. So in a way, really confusing. In a way, not as nasty as we thought, not as new as we thought. It's nothing that we haven't done before. It's just that we've got more terms to deal with each time we write it down, which means there's more opportunities to make a silly mistake. Now, this is going to need some practice, and the questions come up looking a little bit different. I'm not going to ask you to do all of the exercise, but I am going to ask you to do just about half of it. So we're looking at page 16, exercise 1F, question 1, 3, 5, 7, 9, and let the evens in at the end, because question 10 is an absolute stinker. If you can do that, then well done. So I am expecting some questions about this. I love doing these, so please do ask me, and I'm more than happy to go through my my versions of them for any of those. All right, folks, enjoy that. I will put the questions and answers up as I did yesterday on the screen here if you haven't got the book. Okay, cheerio.